Hello, in today's video, I'm going to try a science experiment that I've wanted to do for over 20 years. But first, if you could, subscribe to my channel. I really could use the help and trying to get to 1,000 subscribers. So it all started about 20 years ago at Texas Tech University. I was in a class, a material science class, with Dr. Hashimi, who's a really sharp guy and a good teacher. And he was describing composite materials, something like fiberglass, where you have one material like glass fibers in an epoxy matrix, and that makes an overall stronger material. Well, during that lecture, I thought to myself, what if you could do the same thing but with all metal? So, for example, nickel, iron, and cobalt are all ferromagnetic. They will respond to a magnetic field. If you could have them respond to a magnetic field to take on a shape and then pour molten metal into it and get it to bond to it while it's at the right temperature. You see, if the molten metal was at a lower temperature than the magnetic point of the steel, the Curie point, you could have some sort of a binary composite metal. So for this video, I tried some experiments in that area. The results weren't totally satisfactory, but I did make some interesting discoveries. So watch to the end of the video and you'll see what I'm talking about. Really weird stuff. In addition to that, I like music. It's very inspiring, but I get copyright strikes on YouTube when I use others' music. So for this chemistry montage, please enjoy my own music, written and performed by myself, with melodic influences by Anthony Shank. Thank you. Well, let's talk about the results of the experiment. The aluminum mix, I had some difficulty getting it to bond at all to the steel, as also I had the same problem with the zinc metal mixture. Although this one, you can see it did pick up a bit of the magnetic field there. and that's pretty cool. That's kind of what I was going for, but trying to mix the powdered metal with the liquid metal was like trying to mix oil with water. So I think where I messed up is the copper coating of this iron. What happens is the copper, when you heat it, it oxidizes, and so you have copper oxide. And so the copper oxide, it won't bond with the other metals. I did get some good results, sort of kind of halfway there with the aluminum and steel. Once it gets in a foundry to a very high temperature, I'm able to bond the aluminum and steel. It's kind of brittle, but this was the kind of material I was going for. But it has porosity, and I was hoping I could get it to cast to the shape of a magnetic field, kind of more like this, but with better mixing. So anyway, these are magnetic, so you can tell there's a mixture of iron and aluminum. They're pretty lightweight, so it's kind of a neat material, but we're not quite there yet. Not quite there yet. The cross section is mostly aluminum. And I've got my magnet here. It's not particularly magnetic. But sometimes when you have a failed science experiment, you gotta kind of be open-minded to really looking at the failure closely and seeing if there's any success within it. And some of the alloy that I was going for, or that not, I wouldn't call it an alloy, the composite material that I was trying to make, I actually did get, mostly off the tip of the stirring rod right here. But you can see it's like a strong cement-like material, a little brittle, but it seems to have a pretty high compressive strength because I whopped it with a hammer a bunch to get it off of there. And it is magnetic, so it has iron in it. It just was really difficult to get it to mix, and the temperatures and the flux, you know, the chemical makeup of the flux may not have been ideal, but the fact that these little pieces are magnetic goes to show you that the composite material I was going for, it was created, just not very much of it. There is one interesting thing I've noticed about this material. This is the one that's copper-coated iron filings in an aluminum matrix. It didn't come out that well, but watch this. One side is hot and dry, the other side is cool and wet. So maybe there's something there.